Hello class, and welcome to today's algebra lesson, which is about geometric sequences. By the end of today's lesson, you will be able to identify the two different types of sequences, as well as write and apply the formula for geometric sequences. So a geometric sequence is an ordered list of numbers where we find each term by multiplying by a constant. That constant is called the common ratio, and it can be found by dividing any two terms that are next to each other. The formula for our geometric sequence is an is equal to a1 r to the n minus 1 power. This n stands for any number, so any term within our sequence. This a1 stands for the first term, so the initial value of the sequence. The R stands for our common ratio. That is how much we are changing by each time. And then once again, that N is the number of the term we are looking for. So there are two different types of sequences. The one we're talking about right now, which is geometric, which is that exponential function model, because there's that n in the exponent. The other type, which we looked at earlier in the year, was arithmetic sequences, and that was when we were finding things by adding or subtracting to get to the next term. So our first job is to identify the different types of sequences. In order to do this, we want to compare the numbers. So I'm going to start by looking to determine if it is geometric or arithmetic. In order to do that, I'm going to take my numbers, so negative 15 divided by negative 20. And then I'm also going to do negative 10 divided by negative 15 to see if those ratios, so that division, is consistent. For the first one, we're going to get 0.75. And for the next one, we're going to get 0.6 repeating. So since these two values do not match, our sequence is not geometric. So I'm going to move on to check if it is arithmetic by checking with subtraction. So negative 15 minus negative 20 and negative 10 minus negative 15. Those double negatives turn into positives, so I get a 5 for the first one and a 5 for the second one, meaning that this is an arithmetic sequence because we are finding our terms with a common difference of adding 5. When I come down to this next one, once again, I want to check to see if it is geometric first. So I'm going to do 21 divided by 7 and 63 divided by 21. When I do that, for both of those, I get an answer of 3. And then I could check 189 divided by 63 also gives me 3. So this is a geometric sequence with a common ratio of 3. Common difference is adding or subtracting. That's for the arithmetic sequence. Common ratio is R, and that's for our geometric sequence. This last one down here, I'm going to start with 9 divided by 4, and then 12 divided by 9. And when I do that, for this first one, I'm going to get an answer of 2.25. And for this second one, I'm going to get 1.3 repeating. So those do not match, so that is not a geometric sequence. Then I'm going to double check with subtracting. So that first answer is going to give me 5. That second answer is going to give me 3. Since neither of them match, this would be neither arithmetic or geometric because there is no constant change. And it doesn't matter that it is not, it could be adding, subtracting, multiplying, and dividing. It does not matter. There just is not a consistent pattern. So go ahead and identify this type of sequence on your own. In this case, it is a geometric sequence, and that common ratio is 1/2. If you put it in as 0.5 instead of 1/2, that is still a correct answer. The next thing we want to be able to do is just to find the next 3 terms. So we know that our sequence in this case was being multiplied by 3 halves. So to find the next term, I'm going to do 40.5 times 3 halves, which is going to give me 60.75. Then I'm going to multiply 60.75 by 3 halves, which is going to give me 91.125. And then I'm going to multiply 91.125 by 3 halves, and I get 136.6875. Notice I am not rounding in this particular section. So normally we round to 2 decimal places, but if it is asking you to find the next 3 terms, we're going to go ahead and not round those answers. Go ahead and try this one on your own. So as you as you are multiplying by your 1/4 here, you get 3 and then 0.75 and then 0.1875. So our next goal is now to be able to write the formulas for these geometric sequences. So I need to look at, as I am solving, what this common ratio is. So I'm going to start again by doing 12 divided by 8, which is going to give me 3 halves, or if you prefer the decimal version, 1.5. I can use 1.5 in this particular case because it is a non-repeating decimal. If it was a repeating decimal, we would not be able to do that. We would have to keep it as a fraction. So you are only allowed to use the decimal version of the answer if it is a non-repeating decimal. So I'm going to just go ahead and use the fraction because that's more common. So I've got AN, standing for any term, is equal to my A1, which is that first number in the sequence. So AN is equal to 8 times 3 halves to the n minus 1 power. And that is my general format of my formula for this particular sequence. Go ahead and write the formula for this sequence on your own. So in this case, our sequence is AN is equal to 3072 times 1/4 to the n minus 1. Again, since it's a non-repeating decimal, if you used 0.25 in the parentheses, that is also acceptable. The last thing we can do is use this formula to find any term in the sequence. So when I do that, I'm going to have A, and then I'm looking for the 10th term. So I'm going to say A10 is equal to our equation, which was 8 times 3 over 2 to the 10 minus 1 power. Similar to our last lesson where we were talking about subtraction in the exponents for the growth and decay and compound interest functions. We want to make sure we solve this part first before we put it into the calculator, and that gives us 9. So you would be plugging in 8 parentheses 3 divided by 2 parentheses to the 9th power. And when you do that, you are going to get that A10 is approximately equal to, and now we're going to go ahead and do some rounding. So 307.55 is our approximate value, so we use that about equal to sign because A10 is not equal to exactly 307.55. Go ahead and find the 15th term for this sequence on your own. So we plug in 15 for the exponent. 15 minus 1 is 14 when you plug it into your calculator. And your approximate answer for A15 is going to be 0.000011. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.